Okay, now we are about to start warming up the session today. So, welcome to user developer meetup. And we are going to talk about machine learning on .NET platform. And during that talk, I will give you some examples and some information how to develop machine learning based project on .NET platform. The lecture should not be deep. That's why we decided to name it Getting Started. So, because if you talk so deep, so sometimes the lecture can be boring. So that's why we should talk about just informational about machine learning and mostly focused on some application of machine learning. So my name is Bahrudin. I am Doctor of Technical Sciences, and here is my Twitter account and my email in case you have some questions about demos or some other questions about machine learning. Today we have a sponsor, GUID New company, which we thank to them for supporting this meetup. Unfortunately, yesterday you had a chance to get more information about, but audio was not good, so you had a chance to see some slides from there. Okay, one more time, thanks to our sponsor for this meetup. So, who will talk about today? I am Bahrudin. I am university professor, but also I am consultant software developer over the 20 years. I am 10 years as a Microsoft Most Valuable Professional. First, I was C# MVP, then .NET MVP, and last few years I am Developer Technologies MVP. In machine learning, I'm pretty old. I have a lot of books, papers, conference, but what I most like is my open source project related to machine learning. There are many, but I selected two. GP.NET actually is my oldest machine learning project. I'm developing it since 2006, and since 2009 is on GitHub. Also recently I've developed ANN.NET, a deep learning framework on .NET platform, which is pretty popular. It has more than 100 stars on GitHub. There are my profiles on LinkedIn, on Microsoft page, and also on Code Project, which I am proud of it that I was one of the first members of Code Project portal. I am between 15 million members. I am one of the first one, yeah. And it's actually 20 years ago. Okay, that's about me. So where I'm living in Bihać. This is a Bosnian town, northwest. It's about 300 kilometers from Graz. And it's also well known with the river Una, one of the cleanest river in Europe. Okay, that's about me. One more thing is that you should look at my GitHub profile. There are plenty of repository made by me, mostly about machine learning, so and data analysis. Okay, what we are going to talk about today is actually about machine learning or .NET platform. the talk will be split in three parts. The first part would be about introduction to ML, some talk about AI, ML, what is ML, and at the end of the first third, we will see a one short demo. I call it how to become ML expert in 1 minute because actually you will implement full ML project without typing any code. So we will use it a model builder within the Visual Studio. The middle part would be about ML.NET, a machine learning framework. We will get some quick introduction. And then most half of the talk will be about a full ML project. Actually, I call it phone detector. We will implement the machine learning image classification model into a Blazor application, which the model can detect a legendary Nokia 3310 phone on image. And then we will summarize the talk and open the Q&A section about the lecture and machine learning. Okay, so what we can see here is several scientific field overlapping and show where we can position AI and machine learning. So what is the machine learning? What is AI? AI is actually intelligence demonstrated by machines in contrast to natural intelligence displayed by humans and animals. So AI can be described as an action performed by machine that can be characterized as an intelligence. Since if a human would have to apply the same action, intelligence must be used to achieve the same goal. So when AI is used, actually it makes possible for machine to use experience for learning. Once it's collect the experience, it can produce the output for a new set of inputs in similar way a human does. So under the AI, we can see machine learning. So what's the machine learning? Machine learning is nothing but a set of computer algorithms. Machine learning build mathematical model based on the sample data, which we call training data, in order to make predictions or decision without being explicitly programmed to do so. And then under the machine learning, we can see deep learning and other type of machine learning, but most popular is deep learning. Actually, deep learning is nothing than very special machine learning algorithm implemented on artificial neural networks. All AI and ML stuff can be impossible to implement without math and computer science. So that's why we cannot talk about AI and ML without math and computer science. Usually, mathematicians look on that buzzword like computer vision, data science, and other words, just as this image shows. Yeah. Okay, let's see little details about machine learning. So this is method of teaching computers to make a prediction based on data. Always start from data. So if you have no data, you cannot make any machine learning model. The goal is knowledge extraction. Sometimes we call pattern recognition also. Involves some amount of automation in form of algorithm and computer to do the job, but it requires many smart decisions by human. Recently, we can witness that there is a AutoML, which can completely automate the machine learning process. And that's exactly the first demo we are going to show in near future. When we're talking about traditional programming and machine learning, we can see that traditional programming requires data in programs and use computer to create the output. What's about machine learning? Machine learning requires data, as we already mentioned, requires the output because we need the output to teach a model what is the right answer. We use computer and we get the program. Program actually is build the model which we then use in the production. In sense of how we trained ML model, we can characterize three types of machine learning. First type of machine learning is actually supervised machine learning. This type of machine learning is most popular, and today we are talking about only supervised machine learning, and all demos presented today will be related to supervised machine learning. So it's simple to describe. The best example of supervised machine learning is detecting spam mail in your inbox. The machine learning model connected to your inbox was trained on millions of emails in order to detect if specific mail is spam or not. So during the training, provided data contains input parameters, so-called features, needed for training, but also the result of each email sample. With the result, so-called label, the machine learner know how to train the model. That's why this kind of machine learning is called supervised, because during the training process, input and results of the input are provided. The next type of machine learning is actually unsupervised machine learning. In such machine learning, where the label are not provided during the training process. So how ML can do anything if doesn't know what is the right and what is the wrong? During the unsupervised learning, machine learning tries to find the similarities between the sample of the data. The results of unsupervised machine learning are clusters groups or similar items. The example of unsupervised machine learning can be found in the market, for example. We have data about items bought within the week or longer period. The ML can find the clusters of similar items. The information is very important for the market. And the third type of machine learning is actually reinforcement learning. This is a special kind of machine learning. It's much complicated than previous two. It can be described as a system of environment, agent, and interpreter. Computer interact with the dynamic system, which must achieve the goal. Agents send the action to the system, and the system return state and reward. Based on the return information, agents should calculate the next action. Example of reinforcement learning can be found at playing video game by the computer itself. You can find a simple example of it at my YouTube channel, where I try to teach a model how to play Mario Kart game. So let's see how it looks like for just a few seconds. Okay, so here we have a YouTube video. Actually, this is emulator of Mario Kart game, and what is the right is actually console of the machine learning program. So the application takes the captures the images on the game and process every image by the model. And model decide what Mario should drive left, right, or forward. So it's not well trained, but this is a plastic demonstration how you can teach a computer to play a video game. Okay. Yeah, so you can see more on that YouTube video about that. So the most popular reinforcement learning actually is OpenAI company, which develops pretty amazing um, examples how to play a StarCraft game and other sophisticated video games. When we talk about a supervised machine learning, we can further classify machine learning at classification or regression type of machine learning. What is the classification machine learning? Classification machine learning actually is such a kind of machine learning where machine learning try to predict a label as a discrete value. So this is an example of prediction of the classes, like some types like days in weeks or stuff like that. And also classification can be further classified as a binary classification or multi-class classification. In case we try to predict only we try to predict results which is Boolean, for example, true or false, or yes or no, or male, female, stuff like that. This is a kind of binary classification. Multi-class classification requires that the model can predict more than two labels. In regression, labels are continuous value. So this is like a stock price prediction, time series prediction, etc. Okay, so we got enough information to start with the first demo. I call it how to become an ML expert in 5 minutes. Um, Actually, what we can do here is the following. The problem is that we need to classify three types of iris flower. As you can see on the right side, there is a three types of iris flowers. Sentosa, which is here, versicolor, and virginica. So uh, we provide the data about the 150 measures of sepal and petal of iris flower. What is petal and sepal is shown at this image. So this is a width and high of petal, and this is a width and high of sepal. So we provide the data set and the machine learning model. We will train machine learning model that can recognize those three types. For this problem, we are going to use a model builder. This is an extension of Visual Studio, which actually is automation process of building machine learning model. Okay, so we will open the Visual Studio and try to implement exactly what we saw in the slide. Okay, we create a new project. We will create just a console application. Let it be console app 4. Actually, we need a console app just for the run the extension, nothing else. Okay, so now we have a empty console application, and we will just right click and select add machine learning. So now we have opportunity to create different kind of machine learning models like sentiment analysis, issue classification, price prediction, etc. But for this example, we will try to run custom scenario. When we select custom scenario, then we need to add the data. So the data plays a central roles for any machine learning model. If you don't have a right data, you cannot get and cannot build any model. So first, we will select a file which contains the iris measures. So first, let me select this file. Okay, here we'll just drag it to the project. So if we click on iris data, see we have a 4 numerical values and we have a type of flower. If we select the file, so let's go to desktop and select the iris data. Okay, then it parses the file, and what we should do now is actually select a label. So what is the label? The label is our flower type. And the input column called features actually is our 4 numerical values: sepal length, sepal width, petal length, and petal width. So here is the data preview. Sorry, about first 10 row. So now we should press the train, and the model also recognizes that this kind of machine learning we are trying to achieve is multi-class classification. How it knows that is actually when we specify the label, the modeler see that there is only 3 kind of different value in the label column, and that's why it decided to specify multi-class classification problem. So in case the model wrongly decided for us, we can still select, is it binary classification or regression type of machine learning. Then, so this is our actually input, what we should specify as an input. Beside the machine learning task, actually we should specify how long the trainer should train the model. Since this is very simple task, we just set up the 10 seconds and press start training. So first, we can see that we already get the model which actually achieve 100% accuracy. And the first model, the modeler will select as the best model for our problem. Now we press evaluate and see the results of the model evaluation, which is actually 100% overall accuracy. And the training time was 9.6 seconds. What we can do now is to generate the code for that model. So we just click the code, and the modeler will create 2 projects for us. The first one is console app ML model and console app ml.console application. So the first one is actually the console application which we use to test a model, and the second one actually is the class library which we can include in our any existing project. So as you can see, we still didn't type any code in this problem, but we got everything what we need. So if we select the console app as a startup project and press F5, just to drag the console here, we can see that the program takes some values and perform prediction, and we can see that the prediction is actually 99.77% sure that this is Sentosa, which is actually true. So what's if we look at the code here, we create a single sample data. If we go into that method, we just see that we grab some value from the file. Once we create a sample data object, we pass that sample data object into the prediction method. If we go into the predict method, we can see here that method actually create ML context. We will talk about that later. Then specify model path, then then load the model into the ML context, and then create prediction engine. Once we have a prediction engine, just by calling predict method within the prediction engine object, we can get model results. So here we have everything we need in order to evaluate the model, in order to predict some flower, but also the console application contains a model builder class which actually perform training of the model. So we can beside prediction, we can also make training of the model. So in case we are not satisfied with the model accuracy, we can further perform training on the model and get better results. Regarding the class library, we have just a model, trained model stored as zip file. We have a consume model class which actually implements only one method, how to load the model and create prediction engine and also perform prediction of the model. And we have just two types for model input and model output. So the class library actually is created here in order that you can easily add into your existing project. Okay, that was the first demo of that lecture. Yeah. So what we learned so far is actually that ML is a part of artificial intelligence, that the ML is set of algorithms for extracting the knowledge from the data. We also seen that there is a three kind of machine learning in context how model is trained. We saw the example how in few clicks we can get a model to predict a flower type. So let's see how So let's see how the whole process of building machine learning model looks like. So first, what we did first, we defined the model, we defined the problem, we occur and process the data, we designed the model architecture, then we performed the model training. Model training is actually sub process of that machine learning life cycle because the training process is not so easy to achieve. So we have a different strategy to train the model, but training the model actually consists of several sub steps. We first initialize some weights, we feed a mini batch of data, we calculate the loss in order that we measure how our model is good to predict something. Then we optimize that loss. We should make that loss is minimum as possible. Once we did that, we actually update the weights and the process finished. In case we have a good model, then we move to the testing and evaluation. Otherwise, we repeat that process. Once we once we test and evaluate, we deploy the model. So that's how one machine learning project looks like. So, and the real question we can state here, how I as a .NET developer can be part of this, since all I heard was Python, TensorFlow, ANN, AI, etc. So the answer is ML.NET. ML.NET actually is a machine learning framework completely built on .NET with support to use a TensorFlow and other deep learning framework. What is more important that the ML.NET is built by Microsoft, which is important that behind such a framework stay a respective company. So ML provides you an easy way to build ML model without worry about complex algorithms behind it. Since we already see how one model life cycle looks like, we can now start with building ML models and solving problems by using AI. So ML.NET actually runs everywhere. It can run on-premise, it can run on Azure, you can integrate it into Azure functions anywhere in the cloud. Also, since this is part of .NET Core, it can run on Windows, Linux, Mac OS. Also, it's supported x64 and x86 platforms. What you can do with ML.NET? On this slide, you can see some of tasks which you can solve with ML.NET. Sentiment analysis, product recommendation, price predictions, customer segmentation, fraud detection, spam detection, image classification, sales forecasting, etc. So there are plenty of examples on GitHub project as which you can see here as a machine learning samples. So what is the architecture of ML.NET? ML.NET is classic .NET components. Below ML.NET, you can see only .NET Framework, nothing else. And ML.NET actually contains three main components: eData view, trainers, and transformers. What is iData view? iData view is responsible for data. You can transform the data, you can normalize the data, and you can perform any transformation of the data. Trainers actually is a component which you can select a different kind of ML algorithm in order to build a model. And transformer actually is the object which contains a model, and the model can be saved as an ordinary zip file. Now, recently, AutoML is added to the ML.NET as a completely automatic process for building ML.NET models. And the example of AutoML we seen in the previous demo. What is more interesting is actually extensions of the ML.NET, and the next demo, our demo will be just of using TensorFlow models in order to implement image classification in our application. So there is also extension to ML.NET which you can use TensorFlow models, Onyx models, and other popular deep learning frameworks. And top of the ML, there is three components. There is a UI. We already seen that in the previous example, Model Builder in Visual Studio. You can also perform ML.NET just by using a console command line. And what is also the most popular use of ML.NET is actually through the using of API by C# or F# language. Since ML.NET is classic .NET components, it can be installed by using a NuGet package. This is just the first component of ML.NET, but you need more components when you try to build a model. So the first component you should install is Microsoft.ml. How to train the model? Training the model can be achieved in just a few lines. But first line always start with creation of the ML context. Then you need to load the data. Then you perform some data transformation. Then you set up a trainer algorithm. And then you perform actually the training process by calling the fit method. And this is actually the pattern of training model regardless of the machine learning algorithm you use during the model training. How to consume, which is actually most important, that in any of your current project, you just need to create a prediction engine, obtain the data, and call predict method. And that's what you need to do in your application. So now it's time that we show our main demo. What I prepared for this, actually, it's a brand new demo. You didn't see that demo on the internet because I specially created for this meetup. Actually, this is a Blazor application which contains a page for how to integrate machine learning model into some modern client application. And what I can say for this demo is actually the most common scenario in .NET how to use machine learning. So building machine learning, this demo actually shows how to build machine learning solution from the zero. And also I decided to use a Blazor app because the Blazor actually getting more and more popular as a .NET tool for building client applications. And actually, through the Blazor, we consume the machine learning model, and also beside Blazor, we have one console application for training the model. So complete implementation of this can be already found at the GitHub page called Detector. So this is how it looks like. And now we are going to see the code of this cool application. So here is a Visual Studio solution for Detector. It contains a three project. The first one is actually Nokia 3310.ml.shared. Actually, this is a common class library which share the code between the client and the trainer. The next project is Model Trainer. This project actually creates, train, and deploy machine learning model into the client application. And the client application actually is the Blazor app, which contains um, uh, uh, two pages. Yeah, one is index and one is about. So let's first see the how the application looks like. So if we press F5, so everything is good so far. You can hear me clearly. Everything is good. Can someone confirm? Okay, okay. So I got positive response. Okay. So here is a starting page of the application. This is a Blazor application which contains two pages. The first one is Nokia Detector, and the second one is about that application. In case you don't know the Nokia 3310, actually this is a legendary phone from the 2000, yeah, from 2000 year. Actually, this is the most popular phone ever produced, and that's why I decided to dedicate that application to that phone. Yeah. Okay. So about page is nothing but a copy of the Wikipedia from Wikipedia about manufacturer, what is series of that phone, stuff like that. So the next, the actually the main page is the where we implement machine learning. So how application works, you just select the image. If we select one which is doesn't show the Nokia 3310, then once we load the image, we press detection and we wait a little bit because at first time cold start is takes a little longer. So now we saw the message that this is not a Nokia 3310. In case we select some correct image and press detect, and this is a correct image of the Nokia. Yeah, that's how the application works. So now let's see what's behind that implementation. Uh, First, we are going to see the trainer. So the trainer is actually the console application which collects the image set. What I did actually go to Google image and collect some images from the Google. So you can see here, let's open folder. So when I try to implement that application, I need to obtain the image for training the model and also image for testing the model. The first, I collect the image for training. Since this is an image classification machine learning problem, I should obtain image for Nokia here. I took only 18, but also I provide some images which is not Nokia, uh, because I should teach a model that it can recognize what is a Nokia and what is not a Nokia. So, and also this is just a demo application. The model I provided in the GitHub is not strong enough that can recognize any image you provided. So don't surprise that if you perform some prediction based on your own image and you be disappointed because it not doesn't recognize the image. Uh, in order that you make a model stronger, you should provide much more images than 18 I provided here. Okay. So I provided 18 images of Nokia and also about the same one images that Nokia is not shown. And also I provide some testing images you already saw in the presentation. Once I collect the image data, I start to building my machine learning model. So first, I create a model builder here. Similarly, as we seen previously in demo, what's model builder is implemented. Actually, it contains the path of the training images, actually folder, and contains one method for building and training the model. Once I call that build and train and provide image set and also hyperparameter for image classification, we will see that a little later. Then in the first step, we transform that image into iDataView object. We already mentioned that. Then we shuffle the images in the set. Then we perform some transformations. So since we have a labels as 33, 10, and known, we should map labels as a values because machine learning algorithms only recognize numbers, not words and any other sorry type of information, only numbers. So in that we perform map value to key transformation. Then we load raw images. Actually, what we do here is loading image into the application memory so the algorithm can recognize image as a three-dimensional matrix. So we have a width and height, and we have a three channels, red, green, and blue. So that's what this line is supposed to do. And then we call the fit, which is actually the perform the training. And once we train, we should also transform the images into the back into as a results. And then during that transformation, then we call the multi-class classification, image classification trainer, and pass the hyperparameters. What is hyperparameters? Actually, the parameters which define how trainer will train. So we will answer the. I see some questions in the chat, but we will open Q&A session and try to answer of all questions. And then we define the trainer with hyperparameters, and also at the end we perform some transformation back. So now we need to transform the numbers into the labels to get correct results of the image classification. Then we perform model training. Then we get some metrics to see how model is well trained. And then these lines are actually show the evaluation on the console. At the end, we save trained model. What we hear more in this project, if we go to main application, main method, we see that we just create some logs to see what is happening behind the ml.net. Then we create model builder, the class we already seen. We load the image set, and this is actually definition of the hyperparameters, which is very important. So here we define what is the feature, what is the label, and then here is actually this project use so-called transfer learning. What is the transfer learning? Transfer learning actually means that we already use pre-trained model in our model training. That's why you see very few images on my image set, because I already use Inception V3 Google trained model for image classification, and I just need to train only output layer in order to get recognize Nokia 3310. We define 500 epochs, we define learning rates 0.01, but this epochs and learning rates don't play much, because by default ml.net is set up for early stopping. So once the ml.net recognize that we have a good model, it will stop the training process because it already found a good model. And this is a metrics callback that we see during the training what's going on the when training. And then we call model and build training. So now let's start that model trainer and see how model is trained. Okay, so first it load the TensorFlow model. Then this is something messages of the TensorFlow. If someone use TensorFlow on Windows, it can recognize the same messages. Okay, now the training process has started, and also within the very quickly within the 20 epochs, the model finished. And this is the results. This is a so-called confusion table, which shows that among 18 images, which shows the label, a real Nokia 3310, there is 0 wrongly predicted. And also there is a 16 images which don't show Nokia 3310, and all that are recognized as none. So we have a very, very good model. So now we will try to save that model on disk so we can deploy it on our Blazor application. So I will click yes and press enter, and the model will be stored on disk. So here the process of training is ended. So now if we go to image set, we got a new model. As you can see, this is a plus sign, so this is newly filed. produced by the model trainer. So now we just copy that file and put into the Detector app, which is folder here. I already trained model here and put it here. And then we can set up as a startup project to Detector app and see what's going on there. So once we copy the model, deploy the model into the Detector app here, we can see how this is implemented in the client app. Okay, so now um, we implement a few services in the Blazor app. First one is file upload. You saw that when you press upload image, we implement the service that we upload that image and put that image into the image folder here. Once we have that image into that folder, it can be shown on the page. Once we have loaded the image into the page, we can call detector service, detect. What is detect? How it what's doing? So here we create a ML context. We create prediction engine. Once we create a prediction engine, we just call predict here and get the results. If the results is 3310, then it returns a true. Otherwise, it returns false. So if we go into the page, so this is a page which you cannot see JavaScript. So this is amazing, especially for .NET developer who don't like much JavaScript. So this is a completely page with C# code and HTML tags. So here, this is a Blazor input file, a component for loading the image. Um, Once we select the image, it calls handle file select. What handle file select is doing is here, just call the service upload async and assign the variable file. Once the file is not a null, it just call the image HTML tag and show the image on the page. I can see a lot of good questions on the chat, so I'm very excited to answer on that questions. And that's what the loading image is doing. So now when we press detect here, it calls detect method and it calls service detector detect async. Once the result is true, it color the text in blue and show that text. Otherwise, the text is red. So that's how the Blazor application is implemented. What we can, let's go once again to see the application. Maybe it would be good that we put some breakpoints to see code flow. So here, load the data, press detect, and the breakpoint is activated. So go to here, call detect async. This is first time call. So here is a true, and true is going to that, and the results is here. So this is actually a common scenario of machine learning project implementation into the web application, into the WinForm application, you can actually implement such a machine learning project into the project, into your solution, which is not based on the .NET. You can provide a service with that code and call the service instead of calling the method I did here. Okay, let's back to the slides. So what we can say more about machine learning is the overfitting of the model. This is a most important thing in doing machine learning. And this is actually 1 million question: when to stop with training. When you training, your your accuracy is increasing, but also your test set accuracy is also increasing. And there is a point, early stopping, which is already implemented into the ML.NET, but it works on sometimes, but sometimes maybe your data is complex and you cannot get good model with early stopping. You should remove that. But there is a one point where you get maximum accuracy of your testing set. So training further, your accuracy will decreasing, but your training set accuracy will increasing. So that's which is not good for you. So this is a line uh, of early stopping, which you should always stop the training around that point. Okay, so I also prepare some sentence, some experience what is good to know about machine learning. So the first one is that machine learning means learning from data. Machine learning is about data and algorithms, but mostly data. So that what this means. So if you have a bad data, this is not this is it's regardless if you have a very good algorithms. You cannot get good model if you have a bad data. So that's the fourth statement is machine learning can only be good as the data you use to train it. If the data doesn't contain information about something, you cannot expect that machine learning know about that. So that's the data representative. Most of the hard work for machine learning is data transformation. So data transformation plays a main role in machine learning workflow. Deep learning is revolutionary advance, but it isn't a magic bullet. So as you can see, we use model which actually is trained by deep learning. In that model, there is a lot of different type of neural network layers, and this is revolutionary. But this is not always a good approach for doing machine learning. So machine learning also is highly vulnerable. So it can predict you and it can give you bad information. So be careful about the prediction of machine learning. So, and the most important that AI is not going to become a self-aware, rise up and destroy humanity. So this is not, probably will not to become. Okay, that's all I have, and hopefully I'm finish in 60 minutes. So now I'm going to see the questions and try to answer of some of those. So let me. So let me. Okay. First, good. It would be the internet. Let's leave for private. Okay, Mark. Is there some recommendation for ratio between positive and negative image? Yeah, that's very good question. It must be the same. So you must always have balanced data set. In case you, for example, in the first example, we have 150 measures, 50 measures of each flower type, and that's why we get a very high accuracy because the data set was balanced. Also in the Nokia detector, we approximately define 18 image for positive and as I remember 17 image as negative. So this is also a balanced set. Would we use inception V3 for other object chairs? Yes, there is a several very good pre-trained model. So Inception V3 and ResNet, I think 16. Let me find the internet. Let me find a web page of that pre-trained model, and we can discuss about that. So here there is a lot of pre-trained models. So the Inception I've used the Inception V3. It's about 92 megabytes. It's pretty big. And also this is also a ResNet models are very good. So in case you need to define some image classification on objects, so I recommend to use V3, Inception V3 and also ResNet based models. So this is a classic image classification. This is classic models for image classifications. How many images would we roughly need if we don't reuse the existing layers? Actually, more image means the model will be more accurate. So provide as many images as you can. It's actually when you're using transfer learning, you don't touch weights in the Inception V3 models. You're just training and adjusting the weights of the output layers. Yes. So the next one question is it possible to do this example to get the model with AutoML? Yeah, as you can see here, there is an image classification. There is an image classification. Yeah, you can do that with AutoML. So if you upload a black and white image for Nokia, it will work. Yeah, model doesn't model doesn't care about is it image black and white or in color or anything else. It just it treats the image as a matrix and it learns it extracts the patterns and that's all. No, the next question is, are those 93 megabytes of Inception V3 included in the NuGet pack? No, it's not included. Actually, when you first time try to train the model, you need to wait sometimes that the model is downloaded from the server. So don't you can think that the application stuck, but wait a little bit before the model approximately wait as long as you think that 93 megabytes would be downloaded to your computer. Once the model is downloaded, it actually place it at the temporary folder, and it can reuse next time when you start the application. So that's why you saw that I didn't wait to download 93 megabytes because I already downloaded previously. But what if the pattern are actually colors? For example, if I want to spot white and red roses, how to train that model? That's, yeah. If the color is relevant for your identification, then in that case, you should care about the color. Yeah. In case that you, but let's see if we can perform some tests. For example, let's try to find some Nokia 3310 in color, for example, red. We can find it very easy if we say Nokia 3310 red. So, for example, let's find a good one. So here, I think this is good, but also when you train the model, everything around the Nokia is also take account. So in case there is some text, this is also will be infected by your prediction. So in case that, for example, this text is located on some other Nokia phone, the model will probably be fooled and predict the right, but it's not. So let's save that image and try to predict it. There it is. So that's the model didn't recognize it. Why? Because we have in known some of those red colors. Look, and this is mostly influence the model that thinks this is not a Nokia 3310. So as you can see, I used mostly the same color here, gray, and I can fool that model also with some other phone which is gray and which is very similar to that. That's why you need to provide more images, more variation of the images, more color, more. Actually, you need to provide almost any example you think that it will be happened in the production. Yeah, this is for demo purpose. I wanted that I show you the training process. In case that we use several thousand images, I need to wait pretty much time. Yeah, that is the ML models can be fooled very easy. So any solution machine learning solution should be any developer when building machine learning model should be aware of it. Yeah. So if there is no more questions, I just say thank you very much for your attention. Thank you very much. I hope I gave you a good set of information, good basic, good foundation of machine learning that you can just reuse and uh, um, start with machine learning. So thank you very much and see you next time. Uh, what uh, what about my where is your questions? So Marco, we load the data from Excel server table. Okay, let me. I missed that question. We load data from SQL server table as an input, and we make some prediction based on the data in table. What if data in table is update and we run new prediction? Yeah, once you finish with the training, that's it. You can, in case you have a new data, you can perform so-called retraining. So you can start with the level you already trained. So you can save much time. Yeah. It will not be included. The next question is, will that new data will be included in the new prediction? You can include it, but that will not be included automatically. So once you train and then the table is updated, you need to retrain the model again. Yeah. So first time you train the model, then in case you update the table, you start retraining. Marco, are you satisfied with the answer? Yeah, thank you. So guys, thank you very much and see you next time.